Welcome to our lesson on multiplication of real numbers. What do we do with the negative numbers? So in this lesson, I really want to dive deep into what we do with negative numbers when we're performing the operation of multiplication. I want to look at it different ways. As always, please like and subscribe if you find this video helpful, and leave me a comment or question. Let me know what you liked, what you would like to see more of. So let's talk a little bit about what sign errors are. Sign errors are one of the most common errors in all of math, and I mean that from the moment negative numbers come on the scene to all the way through high school, college, graduate school. Mistakes that are made with negatives are really common. So sign errors have to do with the rules that govern positive and negative numbers, and it's a very broad category that can include messing up the rules when you're operating, to simply adding or dropping negatives off of numbers when you're copying them from one line to the next. One of the reasons sign errors are so common is that people are often taught rules without any foundation behind why they work. And you might have had that experience in your own math classes where a teacher just gave you a set of rules to follow, such as if you add two negatives, the answer is negative, which we will find might get confused with the rules for multiplication. Rules with no foundation tend to be forgotten, misremembered, or confused with other similar rules, which absolutely happens with our signed numbers, because you'll have a set of rules for adding signed numbers, a set of rules for subtracting signed numbers, a set of rules for multiplying signed numbers. And if you don't have any foundation for why those rules are what they are or why they work the way they do, then you will end up confusing one with the other and making all kinds of sign errors in your math work. If you recall from my addition of real numbers video, I emphasized the mental model of the number line and did not present any rules at all for how to add real numbers. The entire lesson was based on picturing the process on the number line and moving left and right and back and forth on the number line. So if you followed that video and did the practice set for those problems, then you already know how to add real numbers without the addition of rules, okay, without thinking about whether you're following rules. And it really gets back into what are we doing when we're adding the numbers. Multiplication is definitely trickier to visualize. So in this video, I will attempt to illustrate why the real numbers multiply as they do, and then summarize with the overall rules. So we'll go through a couple of illustrations for why does this work the way it does. Hopefully that will make some sense to you, and then we'll kind of recap it with, at the end of the day, you just need to remember that this is how multiplication works. So let's start with what is multiplication. Let's go back to the ground level of what are we doing when we're multiplying. Multiplication is repeated addition, addition over and over and over again. In fact, multiplication is a shorthand way of writing addition, which is why in your order of operations, multiplication comes before addition, because it is a group of addition problems. So 2 times 5, looking right here, 2 times 5 literally means 2 added 5 times. So it means this: 2 plus 2 plus 2 plus 2 plus 2. And if you added those up, you would get 10. Or if it is written 5 times 2, okay, it means 5 added 2 times. So 5 plus 5, which is also 10. And you can use illustrations like that to demonstrate the commutativity of multiplication, meaning it does not matter whether you're writing 2 times 5 or 5 times 2. And there's all different unique ways that you can illustrate that. Rectangles are a great way because you can look at the rectangle and the length and the width, and you can turn the rectangle every which way, but you still have the same number of blocks. So building on that definition, -2 times 5 must mean this, because we know that good definitions don't change. They're not flexible yet. So -2 times 5 would be -2 added 5 times. So instead of a +2 there, you've got a -2. And so we're going to fall back on our addition of sign numbers, -2 plus -2 plus -2 plus -2 plus -2 on the number line. And that is going to give us -10. And I really like illustrating it that way because it is grounded in what you already know. Now, if you need a refresher on adding real numbers, please check out my video on adding real numbers. I'll try to link that in the description box, and you can go back and see what the model is for how we're adding them. Thus, negative 5 times 2, okay, this would also work, is negative 5 added 2 times. So we would have negative 5 plus negative 5, which is also negative 10. And what we see from that is that it does not matter which number is negative. Okay, so we can have negative 2 times a positive 5, or we can have a negative 5 times a positive 2. Both of those are equal to negative 10. So we want to note that it doesn't matter which of the two numbers is negative. When we go to multiply them, we end up in the same spot. And if you wanted to do this with a bunch of other numbers other than a 2 and a 5, you are welcome to do that. I think it's pretty clear that it would work for any numbers that you picked. Okay, now if the problem were written the other way, so if you saw a problem that was written 2 times negative 5, it makes no sense to say 2 added negative 5 times. Okay, that's a nonsensical thing. You can't add something in a negative 5 times. And we would use commutativity to express the problem as negative 5 times 2 instead. So if you saw the negative on the second number, we would engage commutativity of multiplication, which means that you can multiply them in either order, and we could write that the other way, and it would bring us back to negative 5 times 2. So in other words, it doesn't matter whether the negative is in the first position or the second position in your multiplication, like you're going to land in the same spot. So let's visualize this on the number line. Okay, so this is the first way we're going to look at this. If we picture the 0 being in the middle of the number line, 2 times 5 brings us over here to positive 10. But negative 2 times 5 brings us the same direction, same distance in the other direction, negative 2 times 5. And we established the same thing, that if it were the 5 that were negative, it would also bring us to the left. So what I want you to notice there is that the making one of the numbers negative constitutes a change in direction on the number line. So the negative 2 brings it over to the negative 10. So instead of moving right, we're moving left, which I believe is the next blur. Okay, notice that multiplying by a negative caused a change of direction on the number line. Instead of moving to the right on the number line, we moved to the left because we were adding a bunch of negative numbers instead of adding a bunch of positive numbers. Now, if we were to graph negative 5 times 2, we would note that multiplying by the negative 5 also results in a change of direction on the number line. And I want to make sure that I'm noting that both numbers independently constitute that change. So what about negative 2 times negative 5? So recapping what we know. If both numbers are positive, we move to the right. If only the 2 is negative, we move to the left. If only the 5 is negative, we move to the left. So what would happen if both the 2 and the 5 were negative? I'm going to let you guys think about it for a second, and then we'll come back and talk about it. If both multiplying by negative 2 and multiplying by negative 5 individually constitute changes of direction on the number line, then multiplying by both at once would mean we have 2 changes in direction. So we change direction and then we change direction again, and that would land us back at the positive 10. So let's just see if we can picture the reasoning there. Okay, so we have our number line, we have a 0. If both numbers are positive, then we move to the right. If one number is negative, we move to the left. But if the other number becomes negative, then we would change directions again and end up being back at the positive 10. So if in this kind of scenario, with this description, we're making it very visual on the number line. although I'm going to number line the next example as well. But you're thinking about the negative as a change of direction. It's like you're moving one way and then the negative is causing you to change direction. So if that pattern holds, if that reasoning holds, then multiplying -2 by -5 would give us a positive 10. So -2 times -5 is a positive 10. So maybe you'd like to see this another way. Okay. Now, this is one of those things where by attempting to explain something multiple ways, sometimes you can make it better, sometimes you can make it worse. I'm obviously endeavoring to make it better. So I want to show you that you can deduce what would happen in both of these cases by looking at patterns in the multiplication. So if the number line, you're just not sold on this changing direction thing, maybe this will make some sense to you as well. So what we have here is a bunch of multiplication problems. So we have all of these are multiplication. I did them on a table. Okay. And what we want to notice here is what the pattern is. So 2 times 5 is 10. 2 times 4 is 8. 2 times 3 is 6. 2 times 2 is 4. 2 times 1 is 2, and 2 times 0 is 0. Now, never one to miss an opportunity to play on the number line. I do want you to notice that the pattern here is that we are moving down by 2 each time. That is an 8. Does not look like an 8. So that's a 4. Move down, we have the 2, and we move down and we have the 0. Okay, so 10, 8, 6, 4, 2, 0. Okay, so the pattern here is that we move left by 2 units each time. So if that pattern continues to hold, then once that 0 comes down to a -1, we are going to continue to move left by 2 units, which means that on my number line down here, we would now be landing at the -2. And from there to the -4, and then to the -6. Okay, and from there to -8, and then we land at the -10. And so this way of visualizing it isn't necessarily the same as the repeated addition, although there's obviously considerable overlap here, but it's picturing the pattern, the numerical pattern, establishing it with what we know works, and then extending that pattern into something new, like, okay, what happens if we're multiplying by a negative? So what's happening on the number line here is we're moving left 2 units. And again, as with the other example, if you wanted to pick different numbers, you could, and you would see the same leftward pattern, just instead of counting by 2s, you might be counting by 3s or 4s or something less convenient. Now, where we end with our conclusion here is that a positive times a negative does indeed give us a negative number. Same conclusion that we arrived at the other way. So if both numbers are positive, you have a positive number. If one of the numbers is negative, then you land at a negative number. We can see from the pattern that a positive times a negative yields a negative. Now what we're going to do is hold the -5, and we're going to bring down the 2 until we have both numbers negative. So what we're going to do is we're going to kind of pick up the table right here at the 2 times -5, but we're going to park at the -5, and now we're going to start to bring down the 2. So we're going to count 2, 1, 0, and then see what pattern we have there. So once again, this is multiplication. Okay, and we're picking up the table at the 2 times -5, which we already established was -10. And we've also established that a positive times a negative would give us a negative. So -1 times 1 times -5 is -5. And of course, 0 times anything is 0. So coming back to our number line, now I'm starting at that -10. The next number is a -5, okay, right there. And what I want you to note is that we went right 5 units. The next number is a 0. And I want you to note that we are right 5 units. And what I like about illustrating it with that number line is that now you're seeing that change in direction. So we went from like moving left, now we're moving right as we're bringing down the other number. So if this pattern continues, then and we go from the 0 to the -1, I should move right 5 more units, which is going to put me at +5. Okay, and when we land in the same place we did before, where now we have a negative times a negative gives us a positive. So -2 times -5 would bring me right 5 units again, and I end up at the +10. So this is another way of illustrating like what's going on with these negative numbers and when we multiply them. So you've actually gotten an opportunity to see it 2 different ways that hopefully these rules are grounded in something that makes some sense. Thus, if the pattern holds, the product of 2 negative numbers is positive. So you can think about it as adding repeated addition, whether you're moving to the right or moving to the left, or you can think about this as like these patterns, and we see the patterns in the numbers. And if the patterns hold, which we have no reason to think that they wouldn't, then we would end up with positive numbers when we're multiplying 2 negative numbers. So I'm not a rules person. If you watch all of my videos, you are going to see I am not someone who hands you a bunch of rules and says just like execute these rules. But there are times where we might need to just summarize some stuff so that we can get it all straight in our heads. So the rules for multiplication of real numbers are this. If you have 2 positive numbers being multiplied together, the answer is positive. So a positive times a positive is a positive. So the example we've been working with this entire lesson is 2 times 5 is 10. And that goes back to early elementary school, whenever you first introduced to multiplication, that like, of course it's positive and you have all the little things on your desk to illustrate it. Now, where it gets new is a positive times a negative will give you a negative, or obviously a negative times a positive would give you a negative. In other words, if the signs don't match. So if you have one number of each. So an example would be -2 5 times, or you could have the 5 be negative, and we saw both of those illustrated. So negative times a positive would give you a negative. And now here's where it gets like a little weird, but if you have 2 negatives multiplied together, then you end up with a positive. And so a -2 times a -5 gives you a +10. Okay, and so a negative times a negative does give you a positive, and you've seen that reasoned out a couple different ways. So those are the summary of the rules. And if these are the only rules you're memorizing and you're not using rules for addition or subtraction, then that cleans up a lot of brain space to just kind of remember these ones, and you don't have to think about other families of rules to think of. And that has typically worked for most of my students. Just a few more examples before we go. These rules will also work for things with variables. So if you have 2 times -6x, we would do 2 times -6, which would be -12. And of course, we would have the x in there. So 2 times -6, 6x is -12x. You could also think of that as -6x 2 times. So -6x plus -6x would give you -12x. Now, it also works if you have 2 negatives. So -2 times -1 would give you +2, and the x would be included in that. And this one is important to note, that multiplying by -1 just changes the sign. So it will make something negative that had been positive, or something positive that had been negative, and that can come in very handy when we get to solving equations and you need to flip the sign of something. And these principles will also work if you have multiple things being multiplied. So this is -3 times -4 times -2. So -3 times -4, that's negative times a negative, that will give you a positive. and then positive 12 times negative 2 will give you negative 24. And something to note with that particular one is that every time you layer in another negative, you end up flipping the sign again. So if multiplying 2 negatives results in a positive, multiplying 3 negatives brings you back to a negative. And if we were to put in like a fourth negative, so times -1, we would flip back to a positive. And that's a useful pattern to remember as well. As always, check out the linked practice set. I'll try to link that in the box up top and in the description box, and leave a comment or question to let me know what you think. See you next time.